This summer intern, I was working on a project of learning relative pose, camera pose for visual localization. My name is Xiangyu Xu, and I was working with Warmpax, and my position is research intern. My mentor is Dr. Li Guan and Dr. Haoxiang Li. Uh, uh, our goal is trying to come up with a competitive end-to-end relative pose regression method. Basically, input a core image and a reference images with norm pose, and we're trying to estimate the relative pose of the core image to the reference image. Contribution, the potential contribution of this project is we will come up with end-to-end relative pose estimation method by using explicit matching and propose a coarse to fine matching strategy. And we're going to use coarse matching label for supervision. The overview of this presentation, first, the gonna introduce some state-of-art methods solving relocalization problem, and our which part of we're gonna focus on, and some efforts we did to improve the relative pose estimation. Then we're gonna introduce our coarse to fine implicit coarse to fine matching strategy, and finally outlier filtering module by weighted 8-points algorithm, and then some future work. There are many directions to solve the visual relocalization problem. We're gonna focusing on using deep network to estimate the relative pose between images. The advantage of this kind of method is it's going to be a lightweight network, and can be end-to-end trained on different conditions. And disadvantage will be is have currently method have very low accuracy. That's what we're trying to overcome. To solving the relative pose, the state-of-art method, for example, the classical feature matching solution, trying to estimate first estimate some key points and descriptor of local image patch, then find find a matching between the feature of two images, then solve the essential matrix based on 5 points algorithm or 8-point algorithm. Then trying to filter the some outlier based on ResEq. Some other researchers trying to solve this problem using deep network, basically trying to estimate the global feature from the pair of images, and then regress the relative pose based on the global feature of two images. However, the deep network-based relative pose regression problem is still not compatible with the classical method, actually much worse. And that's our goal to come up with a deep network version of solution can be compatible with the classical, probably have better result on a challenging condition. And we can introduce some efforts we did to improve the relative pose estimation. First, we're trying to do a multi-view pose recognition based on the feature of core image to multiple reference images. However, the improvement of the result is very small and still not compatible with the classical method. The reason for that probably is this kind of direction you're trying to extract the global feature from the images. There's no feature mapped to the specific pixel position, which compared to the classical one is trying based on the matching of future of local position of the images. Then we're trying to extract the local future and with specific position on the images and regress the relative post based on the local feature and position information. However, it still cannot be properly learned or by this way, and most probably region is the regression layer, which basically the fully connected layer cannot exactly learn the matching information from the local feature and the position information compared to the classical one using directly the feature matching result and the geometry information. Then we're trying to using the explicit matching result from the feature. We're trying to regress the matching result from the reference image, from the core image to the reference images, and input the eight-point algorithm as the end-to-end learning. However, the matching result is very bad. For example, below. The reason for this is in this matching method, there is no disparity constraints. Basically, the matching for key points are estimated from the whole region of the reference images, which is very hard to find. And we're trying to do an experiment to restrain the matching on small region on the reference images, which can be matched much better. So the problem is we're gonna first constrain the matching to a small region, and then we come up with a coarse to fine matching strategy. First, for the reference image, we're gonna extract the different level feature with different resolution, and basically the coarse match is from key point to match a region on the images, and gradually matching to a small region on the reference images, then gradually find to a small region. And finally, we only trying to find regress the matching position on this small region based on a fully connected layer as a regression layer to find a matching position. Here is some results to train with. This first step is training only the coarse matching to align the matching to a small region, and finally it's reasonable the matching error is about 10 pixels because you will match to the right region is not exactly the position. Then some training with fine matching will down to few pixel error matching. Here's some example for the coarse matching. Basically, the key point is matched to a region in the reference image, and then the refine matching. The matching result is much close to the ground truth. The average error is about 3 pixels. Example of a white baseline matching result. The matching still reasonable. And finally, we're gonna have a weighted 8-point algorithm as a replacement for the RenSec as a outlier filter. So this is basically the framework of our whole network. First is filter extraction, then coarse to fine matching, and finally filter outlier based on weighted 8-point algorithm. And some depths are using to generate coarse matching label. Some future work, we're gonna train and testing on more larger data sets, and training and testing on some challenging data set. For example, all outdoor and day-night and different season data. Compare with some state-of-art visual localization method. For example, here the method list below. Also, the feature matching result is is a byproduct of our method. We can also compare this with some state-of-art feature matching method, for example, Superpoint. And during this internship, we have a framework for end-to-end training, end-to-end framework to do a post regression. There are much more experiment to do, and it will be done after the internship. And okay, now another. That's all the result we have, and thank you for listening.